Hello, this is Farhan Shakil from the Republic 2.0, and I'm back with the part 3 of the edexcel 8PHO/01 May 2023 paper. In the last part 2, I've solved almost the first 13 questions of this paper. Now we'll restart from the question number 14, and the question number 14 is right on your screens. So question number 14 says that a student connects a filament bulb to a battery. The battery has internal resistance. The student connects an identical bulb in parallel with the first bulb, right? With the first bulb as shown. He continues to connect identical bulbs in parallel. The student observes that the bulbs get dimmer as more bulbs are connected. He also observed that the temperature of the battery increases. So we need to explain these observations. So first of all, if you guys remember, before I get to the answer of this question, he is connecting all these resistors in parallel. If he's connecting all these resistors in parallel, and we do know that the parallel uh, total combination is R1 times R2 divided by R1 plus R2. In simple words, as you connect the resistors, as you connect things in the parallel, the resistance keeps on decreasing, right? That is the main point of this question, which we need to keep in mind. Okay, so we'll start with the first point, and the first point should be that as the student keeps on connecting bulbs in the parallel, the resistance would keep on decreasing, right? The resistance, first point is going to be that the resistance of the circuit keeps on decreasing. That is the point number one of this thing. And the second thing, as the resistance decreases, what does that mean? That the current in the battery increases, because resistance is the opposition to the flow of current. If it is decreasing, what does that mean? The current in the battery keeps on decreasing. Similarly, in the third point, we can talk about like the potential difference, right? We can talk about the potential difference. The potential difference across the battery or the internal resistance, potential difference across the internal resistance or the battery would increase as well. And as the potential difference across the battery going to increase, the terminal potential difference of the battery going to decrease. Same is the thing, by just using E is equals to V plus IR. By using this formula, we can eventually say that the terminal potential difference would decrease. And as the terminal potential difference would decrease, so bulbs would glow dim, right? In the fifth place, when you're talking about it, what does that mean? If you're having a less terminal potential difference, what does that mean? That the energy transferred from the battery would somehow, increase. Energy transferred from the battery would increase. And as you're going to increase the energy transfer from the battery, on the sixth point, we need to remember that the thermal energy, would increase in the battery. So, these are the simple points which we need to mention for this question. He was just talking about that why the bulbs got dimmer. And, the bulbs got dimmer when as you keep on connecting the resistances in parallel. Now we'll get to the question number 15. And in question number 15, the bullet of mass 12 grams is moving at a speed of 450 meters per second. The bullet hit a soft wooden block of mass 2.5 kilogram, which was attached to the wire as shown. The bullet becomes stuck in the wooden block, which swung upward. Show that the momentum of the bullet is 5 kilograms meters per second. So yeah, that's quite easy. P is equals to mv. You can see that your mass is 0.012 kilograms and your velocity is 450 meters per second. You're just going to times them up. And after multiplying them up, you would simply be having something about 5.4 kilograms meters per second, which is about around 5. Similarly, determine the maximum change in the vertical height of the wooden block. Now we need to calculate the maximum change in the height of the wooden block. So as you know that the kinetic energy of the bullet would translate into the potential energy gained by the wooden block. So that is why using the law of conservation of momentum, we can keep the kinetic energy equals to the potential energy. M and M gonna cancel out. And since you're looking for the height has to be, V square divided by 2g. Now I'm just gonna plug in the values. You've got the speed. If you remember the speed of the thingy, uh, well, first of all, yeah, we do not have the speed of the, what do you call it? The wooden block. So first of all, we need to calculate the speed. And speed gonna be the momentum translated was 5.4, right? And the total mass, because the bullet was it was somehow was ingrained inside the wooden block, so it has to be, the total mass has to be 2.5 plus 0.012 times v. We can calculate the v from here, and v comes out to be 5.4 divided by 2.512, and by just dividing them up you got to yourself something like 2.1 meters per second. So that was the velocity gained by the bullet, by the block. So by just plugging that value over here, I would be having 2.1 square divided by 2 times 9.8. And when you're going to solve it down, you should be having the final height as something like 0.24 meters. So that is the maximum change in the height of the of the wooden block. Now, in the part B, the soft wooden block was replaced with a hard steel block of the same mass, right? An identical bullet was fired at the steel block with the same speed as before. The bullet rebounded from the steel block. Explain why the steel block moved through a greater maximum vertical height than the wooden block. So first of all, we need to talk about that why the steel block could move a greater maximum vertical height than the wooden block, right? So first of all, since the bullet final momentum turned out to be negative, since the bullet final momentum was negative, one can conclude that it had a greater change in momentum because it somehow moved backwards, right? And somehow when it moved backward, what does that mean? So delta P, change in the momentum of the steel ball, change in the momentum of steel ball would also be higher as compared to the wooden block, because if the momentum has to be conserved and the bullet is moving back, what does that mean? The steel should be having a higher momentum as compared to the wooden block. And since if it is having a higher wooden block, what does that mean? That it should be having a higher initial velocity. And if it is having a higher initial velocity, what does that mean? It must be having a higher kinetic energy. Higher kinetic energy means large gain in potential energy. Higher kinetic energy means the large gain in the potential energy. And higher potential energy means, if you've got a higher potential energy means greater height gained, right? So that is why the steel ball moved a greater height as compared to the wooden block. Now we have got the next question. And the next question is that student released a trolley from the top of a ramp of length of about 1.5 meters. As shown, the student investigated how the speed of a trolley at the bottom of the ramp varied with the height of the ramp was increased. The student placed a light gate connected to a data logger at a position A to measure V as the car passes through the light gate ramp. How would you measure, that's quite easy. How would you measure the H accurately? First of all, if you want a very usual or a common way to measure out this height, you can use a meter rule. But if you want to be very accurate and you want to keep your ruler exactly vertical to calculate this height, you should be using a set square. Since it was also a 2-marker question, so that is why I'm giving them two instruments, meter rule has a less accuracy as compared to the set square, because with the help of set square, you can keep your ruler exactly vertical in the direction of h. Now the B part. The student derived the following equation for the motion of the trolley, where g is an acceleration due to the gravity. Explain why plotting a graph of h against v square will produce a straight line. Well, if you could just compare this equation, h is equals to v square upon 2g, compared with the equation of the straight line, which is y is equals to mx plus c. So we can also write it like this: h equals to 1 upon 2g times v square plus 0. So what does that mean? Whenever you're going to plot h and v square, you should be having a straight line with a gradient 1 upon 2g and with a y-intercept at 0, right? Meaning thereby your curve must be passing through the origin as well. So it should be a straight line. You can see that. I've compared it with a straight line equation. The student varied h and measured corresponding values of v. The results are recorded below. You've got this h, you've got this v. Plot a graph of h on y-axis and against v square on the x-axis on the grid opposite. Use an additional column in the table for your processed data. So that's quite easy. You just need to take the h on the y-axis and you just need to take the v square on the x-axis, and you would be having a very straight line. I'm not plotting a graph. You know, I'm just drawing a superposition data. So it must be a curve like this, right? With h on the y-axis and v square on the x-axis, right? That is how we're going to plot this graph. In the part 3, the student used her result to plot a graph and determine the value of g. She concluded that her value was consistent with the value of g given on the data sheet at the back of this paper, which is 9.81, of course. Comment on the student's conclusion. How can you, conclude how can you conclude these statements? So how the student might have, calculated the value of g, since he calculated the graph between h and v square. So she must have calculated the gradient, which was equals to 1 upon 2g, right? For example, if she's having a gradient m, which is x, which could be anything. And how can you find out the gradient? By using different methods. You can use a large triangle. You can use a tangent method. You can use the 2-point form, right? And whatever method you're using, you'll be having x. X is equals to 1 upon 2g. So swapping x and g, you would end up having g is equals to 1 upon 2x. And by just multiplying the gradient by 2 and taking the reciprocal of it would get you the g. Is that clear? That is how we're going to get the value of g. And it must be somewhere in between, 9.5 or 10 or 10.1 or something like that. It must be fine. Okay, now we have got this question number 17. And in question number 17, what we're going to do, a lift is positioned at the first floor of the building. It is suspended by 6 identical steel cables of length 50 meters. Calculate extension in each of the lift cable. Extension means we need to calculate delta x. Cross-sectional area of the cable is this thingy. Young modulus of the steel is 200 gigapascals. And then we have got the weight of the lift as well. And that weight of the lift is this thing. So how can we calculate the extension if we are having a strain? But the thing is that we do not have the strain, right? And if we do not have the strain, we cannot calculate the extension. So first of all, I'm just going to calculate the stress, which is F upon A. I've got the force, which is going to be the load of the weight, which is the weight. And that's going to be 12 times 10 raised to the power of 3 divided by the cross-sectional area, which is 3.1 times 10 raised to the power of -4. I'm just going to divide them up, and I would be having 6.45 times 10 raised to the power of 6. That is how you're going to get yourself the stress. Now, I'm going to talk about the Young's modulus. So the Young's modulus is going to be the stress upon strain. You've got the stress, that is 6.45 divided times 10 raised to the power of 6 divided by the strain. So the strain is going to be 6.45 times 10 raised to the power of 6 divided by the Young modulus. The Young modulus is 200 gigapascals, yani 10 raised to the power of 9. By just calculating it down, I would be having 3.23 times 10 raised to the power of -5. That is how we're going to calculate the strain. At the end of the day, I'm just going to talk about the strains. Strain is delta x upon x, the original length. So the extension comes out to be original length times the extension. Now, if you think about the original length of the cable was 50 meters. So 50 times the strain, and the strain is 3.23 times 10 raised to the power of negative 5. And I would be having 1.61 times 10 raised to the power of negative 5 meters. So that is the extension we're looking for. Okay. Ji? Now, calculate, the 10 people enter the lift, right? 10 people are entering the lift, move upwards, and stops at the top floor of the building. The graph shows the total tension forces in the cable during this time. So you can easily see that, uh, you know, 10 people enter the lift. 10 people, is a number of people that the lift got. The weight of the lift is 12 kilonewtons. If 10 people entered into the cable, the weight or the tension acting in the cable comes out to be 19 newtons, right? 19 kilonewtons. So what does that mean? The total weight of the people is going to be 19 minus 12 kilonewtons. And that comes out to be 7 times 10 raised to the power of 3 newtons. Once you've got the weight of the people, what I'm just going to do, I'm just going to calculate their masses. So masses of the people going to be 7 times 10 raised to the power of 3 divided by 9.81, and it comes out to be 714 kilograms. So 714 kilograms is the mass of the people. Explain the motion of the lift between 5 seconds and 29 seconds. So we just need to explain the motion of the wave between 5 seconds and the 29 seconds. So you can see that the 5 seconds starts it from here, and until we have got something like, this is uh, 6.5. So this is going to be 6.5. So from 5 to 6.5, there was a resultant force acting upward on the cable, right? So first of all, I'm just going to mention that from 5 to 6.5, there is a resultant force acting upwards. You should not write it like this. You just need the resultant force acting upward. A very good line. And we've got that. Now from 6.5 seconds to 25, 26, 27, 27.5. So now you can see that from 6.5 to 27.5 seconds, there is no resultant force acting on the cable. You can see that the wire is constant. And as soon as you reach 27.5 seconds, so 27.5 seconds, we were supposed to explain it up till 29, until 20 seconds, there is a resultant force acting downwards on the thingy. So there is a resultant force which is acting downwards. Got it? So that is how we're going to talk about it. Now, when the lift is empty, a technician removes one of the cables for the maintenance. Assess how removing one cable would affect the extension of the remaining cable. Well, that is for sure. If you're going to remove one cable, what does that mean? Tension, upward force, or the downward force acting on the cables would increase. So tension would increase. And as the tension gonna increase, what does that mean? The forces has been increased. So what does that mean? That the stress would increase as well. Stress would increase it as well. And as the stress increases, the strain of each cable would increase. So the extension would be greater. So you would be having a greater extension by having a higher stress as well. So that is what we're going to do. And that is it. We're done with the 23 past paper of AS level edexcel. Thank you very much. I'll come back with the next video on the same YouTube channel.